All right, this is what's going to happen. We got, all right, y'all ready to listen? Look, essentially what you're doing is, since we're setting it equal to 0, I can pull this over to this side and have negative sine of x equals to the cosine of x. So, if I wanted to know where cosine of x equal to sine of x, cosine of x equals to sine of x at pi over 4. Because it's equivalent to 45 degrees. And think about it, if you draw a 45, 45, 90 triangle, you've got the same opposite and adjacent. So sine and cosine are the same at pi over 4. Also, you can use the unit circle right here. You know, this is the cosine, this is the sine, they're both the same. But here we need to have where they're the same but with opposite signs. And that happens over here at 3 pi over 4. So we're going to get x equals 3 pi over 4. Is there a question about that? I think I told Cola the wrong answer yesterday in class. I hope so, because I'm feeling bad about myself right now.
She probably was like, oh, well, that's like she's one of those people that looks at pen and say the answer
All right, well, let's get back off of that time. Anyway, all right, so 3 pi over 4 is going to be, so this one's actually going to have a critical number in it. So what do we do here? We found a critical number. What do we do with this critical number? Not to the original. We'll plug into the derivative. What are we going to plug into the derivative? No, we know that'll be 0. I know if I plug in 3 pi over 4 here, I'll get 0. Two pi is not in the interval. You just like saying it too. Yeah, something in the intervals.
1.
Well, let's not use 1. Even though 1 would be in that interval. Let's use pi over 2, yeah. So I'm going to plug in pi over 2 here. So 0 equals to the cosine of pi over 2 because it's between 0 and 3 pi over 4. Because I know a lot about pi over 2. Plus the sine of pi over 2. Alright, what's the cosine of pi over 2? It's 0, right? What is the sine of pi over 2? 1. And what is 0 plus 1? Positive, right? So we are increasing here. Okay, so we got increasing here. Alright, well, what's the number between 3 pi over 4 and pi? Not 1. Alright, again, 3 pi over 4 on the unit circle would be right here at 135 degrees. Pi's here at 180 degrees. Huh? 6 pi over 4 is the same thing as 3 pi over 2, which would be down here. Alright, if you don't know, you can always do this. This is a little trick. If you add these two together and divide by 2, you'd be finding the average of these two values, right? If you find the average of two values, it's always going to be between the two. So let's find the average of these two values. We get 5 pi over 8. Now the bad thing about 5 pi over 8 is we don't know what its value is. 150 degrees though is in here and it's 5 pi over 6. So let's go with 5 pi over 6. Alright, so I've got the cosine of 5 pi over 6 plus the sine of 5 pi over 6. Now the cosine of 5 pi over 6 is going to be negative because you're in the second quadrant. And it's going to be the negative of the square root of 3 over 2. And then 5 pi over 6 has a sign of 1/2. Now, what is greater, the square root of 3 over 2 or 1/2? Square root of 3 over 2 is, because square root of 3 is a little bit greater than 1, right? So this would be 1 point something over 2, where this is just 1 over 2. So this is going to be greater. So if the negative value is greater and we're adding it to a lesser value, what do we know about it? It's negative. So we're going to be negative and we're going to be decreasing here. That was a lot of work to get there, wasn't it? But that's okay. We're one. All right. So the intervals where it's greater than 0 would be what? Yeah. Yeah. We'll go from 0 to 3 pi over 4. Now we got to put a parentheses with 3 pi over 4. We can't put a bracket there because at 3 pi over 4, what was the slope again? 0, and 0 is not greater than 0, so we would have to put the parentheses there. We'll need to put the open bracket at 0 because if you plugged in 0, you would actually get a positive answer. So there we go with that. All right, on to the next one. Next one says find the value of C where the average rate of change is. So again, that's just the mean value theorem again. We don't need to go through that again, do we? All right. Now let's look down at problem number 3.